What is the dying ReLU problem? Imagine training a neural network and suddenly noticing that many of its neurons have stopped firing. They just output 0 all the time, no matter what input they get. This strange issue is known as the dying ReLU problem. It happens when neurons using the rectified linear unit activation function become permanently inactive. The ReLU function outputs the input directly if it is positive, but if the input is negative or 0, it outputs 0. When a neuron's input keeps falling into the negative range, its output stays at 0. Because the gradient of ReLU is 0 in this negative zone, the neuron's weights don't get updated during training. This means these neurons stop learning altogether and are considered dead. This problem can reduce the network's ability to learn complex patterns because dead neurons no longer contribute to the model's decision-making. ReLU is popular because it helps avoid the vanishing gradient problem that older activation functions faced. It also speeds up training by activating only some neurons at a time. But the dying ReLU issue mainly occurs due to high learning rates that cause large weight updates, pushing neuron inputs into the negative zone permanently. Negative bias values can also shift neuron inputs toward negative values, regardless of the data. Improper data preprocessing might lead to many inputs being negative for certain neurons, increasing the risk of them dying. When many neurons die, the overall learning process slows down, and the network might underperform. If a large portion of neurons become inactive, the network's capacity to model data becomes limited. This can lead to slower convergence or even a failure to learn important features. To fix this, researchers developed variants of ReLU like Leaky ReLU, Parametric ReLU, and Exponential Linear Units. These functions allow a small, non-zero gradient when the input is negative. This way, neurons stay active longer and continue learning, preventing the dead neuron problem. Understanding this issue is especially important in the context of deep learning and specialized artificial intelligence. Large models like ChatGPT, DALL, and Midjourney relying on millions of neurons working together efficiently. Activation functions play a key role in how well these models learn and perform. Recognizing the dying ReLU problem helps in designing more robust networks and choosing the right activation functions or training strategies. This ensures the models can learn faster, more reliably, and with better accuracy. In essence, the dying ReLU problem is a challenge where neurons become inactive by constantly outputting 0, which hampers learning. Being aware of this issue and applying solutions like alternative activation functions can make a big difference in building effective deep learning models used in many AI applications today.